Hi all. Once again welcome to the lecture of linear control system of KTU syllabus. So today we are going to discuss the response of underdamped second order system for unit step input. As we know, the standard form of closed loop transfer function, that we already learned, that is of a second order system is C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. Here the value of zeta for an underdamped system, the value of zeta will be in between this 0 and 1. That is, the zeta will always be less than 1. So we know that the roots of the characteristic equation, that is the denominator polynomial here, that is when the denominator polynomial is equated to 0, it becomes the characteristic equation. So the roots of the characteristic equation are s equal to minus zeta omega n plus or minus omega n into root of zeta square minus 1. When the value of zeta is less than 1, the term under the square root, that is zeta square minus 1, always be negative. If the value of zeta square is 0.5, then it will be minus 0.5, root of minus 0.5, and if it is 0.75, then the root of minus 0.25 you will get. So always it will be negative. So we are just rearranging the term, that is to taken out the term j. For that we are taking outside the minus 1 term from the zeta square minus 1 into 1 minus zeta square, and we know that the root of minus 1 will be the j. And the solution becomes minus zeta omega n plus or minus j omega n root of 1 minus zeta square. And we know that the damped frequency of oscillation omega d is omega n into root of 1 minus zeta square, that we are going to substitute here. Instead of this term we are substituting omega d. So s becomes s equal to minus zeta omega n plus or minus j omega d, and this is the solution. And for finding the response c of s, this is in s domain. Actually we have to find the response in time domain. That is Laplace inverse of this c of s. So we know that c of s by r of s is this equation, and we know that we are giving a step input. So the r of s become 1 by s. Actually the unit step means r of t is 1, but the Laplace transform of this r of t is r of s, and it is 1 by s. And we are just substituting 1 by s instead of this r of s here. So c of s become omega n square divided by s into s square plus 2 zeta omega n s plus omega n square. And we have to take the Laplace inverse of this c of s for obtaining the c of t. That is our time domain response, that is c of t. And we can find the inverse, Laplace inverse, using some partial fraction technique to split the large term. This is a large term, so we can split into the term with the denominator s and another term with the denominator s square plus 2 zeta omega n s plus omega n square. So it is like that, that is a by s plus bs plus c divided by s square plus 2 zeta omega n s plus omega n square. So as per the partial fractions rule, this is a quadratic equation. So the constants will be b and c. It will be bs plus c, like that. So we have to find a, b and c. You can use any method to find this a, b and c. That is, either you can cross multiply this a with the s square plus 2 zeta omega n plus omega n square plus bs plus c into s. And we can equate the coefficients of the square term and coefficients of the s term. And by that we can find a, b and c, or any method you can use. So here for finding a, we are using a method, that is the entire transfer function, that is c of s. Entire response c of s is multiplied with s, because the s is the denominator of a. Here you can see s is the denominator of a, and we are going to multiply this entire c of s with s. And we are equating the value of s as 0. Because the root here, the value of s will be 0. Solution of s is 0 here. And a is equal to s into c of s at s equal to 0, and it becomes, if you are giving s equal to 0, this and s will be cancelled, and this term will become 0, and 2 zeta omega n s will become 0. At last we will get omega n square by omega n square is equal to 1. So a will be equal to 1. And b and c, are found by using the cross multiplication technique. Okay, that is, we have just cross multiply these two times, and it is equal to omega n square in the left hand side. Okay, so also we know that we have found the value of a as 1. Just substitute the value of a is equal to 1 in the equation. Okay, so the equation becomes omega n square is equal to a into, that is 1 into s square plus 2 zeta omega n s plus omega n square plus bs plus c into s. Okay, that is, you can see here omega n square is equal to s square plus 2 zeta omega n s plus omega n square plus bs plus c into s. Okay, and by this bracket, okay, we have disclosed the bracket as bs square plus cs, and by equating the coefficient of s square, we obtain that in the left hand side there is no s square term, so we are getting to 0 is equal to, here the coefficient of s square is 1 and here the coefficient of s square is b, so 0 is equal to 1 plus b, so b will be equal to minus 1. And equating the coefficient of s, that is, we will get it as 0 is equal to coefficient of s is 2 zeta omega n and c. Okay, so 0 is equal to 2 zeta omega n plus c, so c will be minus 2 zeta omega n, and substitute the value of a, b and c in the equation here. Okay, so a will be 1, so 1 by s plus b is minus 1 and c is minus 2 zeta omega n. Okay, so here you can see we have just substituted the values in the response c of s, so 1 by s minus s plus, so here the minus is common for the entire time. Okay, okay, so c of s is equal to 1 by s minus of s plus 2 zeta omega n by s square plus 2 zeta omega n s plus omega n square. Okay, and for finding the Laplace inverse very easily, we are just adding and subtracting some terms in the given equation. Okay, that is, we are just adding zeta square into omega n square to the denominator. Okay, we are adding and subtracting this term in the denominator polynomial, that is zeta square plus zeta square omega n square minus zeta square omega n square, that's you can see here. Okay, so if we can write these three terms, that is s square plus 2 zeta omega n s plus zeta square omega n square. Okay, that you can see here we have written the terms together here, and we can simply replace this entire term, that is s square plus 2 zeta omega n s plus zeta square omega n square with s plus zeta omega n all square. Okay, this is the expansion of this term. Okay, so for we can simply replace this term with this one, and also the remaining terms are plus omega n square minus zeta square omega n square. In that we are taking outside the term omega n square, and it becomes omega n square into 1 minus zeta square. And also we know that the omega d, the damped frequency of oscillation omega d is equal to omega into root of 1 minus zeta square, which means we can substitute omega d square instead of this term here. So the entire equation becomes 1 by s minus s plus 2 zeta omega n divided by s plus zeta omega n all square plus omega d square. Okay, and we are just going to split this term, this second term, okay, into two. That is, we know that it is 2 zeta omega n, so we can write zeta omega n plus zeta omega n. Okay, also keep in mind that the minus sign, okay, the minus sign is common for these two terms. Okay, and the equation becomes 1 by s minus s plus zeta omega n by s plus zeta omega n square plus omega d square minus zeta omega n by s plus zeta omega n square plus omega d square. Okay, that is, we have just split this term into two. Okay, and we know that this minus is common for the entire term, so it becomes negative here. Okay, so this is the c of s, entire value of c of s. So when we are observing this equation, we know that it is something like the Laplace transform of sin omega t and cos omega t, like that. Okay, this is in the form of s by s square plus omega square, that is the Laplace transform of cos. Okay, so we can simply find the Laplace inverse using this type of some rearrangements. Okay, and in the next step you can see in the third term. Okay, in the third term we are going to just multiply the term omega d in the numerator and denominator. That you can see here, we have just multiplied the omega d in the numerator as well as in denominator. Okay, and next we are going to find the Laplace inverse c of t, that is L inverse of c of s. So we know that the Laplace inverse of this 1 by s becomes 1 here, and that of s plus theta omega n by s plus theta omega n square plus omega d square. Okay, it is the actually this one is the Laplace transform of this term, that is e raised to minus theta omega n t cos omega dt, because we know that the Laplace transform of e raised to minus a t sin omega t. Okay, and the Laplace transform of e raised to minus a t cos omega t. Okay, this will be s plus a divided by s plus a square plus omega square. Okay, s plus a by s plus a square plus omega square. So by comparing these two terms, okay, this one and this equation, we know that instead of this value of a, we are having theta omega in here. Okay, instead of this value of omega, we are having omega d here. Okay, so the equation becomes e raised to minus at, that is instead of this a, we are having theta omega n, so it becomes e raised to minus theta omega n t, and cos omega t, instead of omega we are having omega t, so cos omega dt. Hence this equation comes. Okay, and also we know that here the Laplace transform of e raised to minus a t sin omega t will be omega. Okay, this is omega divided by s plus a square plus omega square. This is not omega square, this will be omega. Okay, omega divided by s plus a square plus omega square. So this is in the next term, this term. Okay, this theta omega n by omega d will be remain as a constant, and this will be in the form of the e raised to minus a t sin omega t. Okay, so instead of this a, we are having theta omega n, instead of this omega, we are having omega d. Okay, so the Laplace inverse becomes e raised to minus theta omega n t sin omega dt. Okay, hence the response will be 1 minus e raised to minus theta omega n t cos omega t minus theta omega n by omega d e raised to minus theta omega n t sin omega dt. Okay, and we are taking outside e raised to minus theta omega n t, and the equation becomes like this. Okay, and also we are taking outside this root of 1 minus theta square outside the bracket. Okay, you can see here, that is the equation becomes root of 1 minus theta square cos omega dt. Okay, this will be get multiplied with this term plus theta omega sin omega dt. Okay, this omega n and omega n get cancelled here. Okay, so just rearranging, just exchanging these two terms, this becomes 1 minus e raised to minus theta omega t divided by root of 1 minus theta square into sin omega dt theta plus cos omega dt into root of 1 minus theta square. Okay, and we are going to substitute this term theta and root of 1 minus theta square. Okay, that is making the large expression with a small one. Okay, that is by considering a right angle triangle having sides 1 root of 1 minus theta square theta, we know that the value of sin theta will be root of 1 minus theta square, and cos theta will be theta. Okay, and instead of the value of theta, we can substitute cos theta, and instead of value of root 2 1 minus theta square, we can substitute sin theta. Okay, so here instead of this theta, we are going to substitute cos theta, and instead of this value of root of 1 minus theta square, it is sin theta. Okay, so the equation becomes here, and it is in the form of sin a cos b plus cos a sin b. We know that sin a cos b plus cos a sin b is the expansion of sin of a plus b. Okay, sin of a plus b, as we know sin of value of sin. Okay, that is sin of a plus b. Okay, this is in the form of sin of a plus b. Sin of a plus b means sin a cos b plus cos a sin b. Okay, so here the value of a becomes omega dt here, and b becomes theta, so it becomes sin of omega dt plus theta. Okay, you can see here sin omega dt cos theta, that is sin a cos b plus cos a sin b. Okay, that is sin of a plus b. Okay, where the value of theta is tan inverse root of 1 minus theta square by theta. Okay, so this is the response of the system. Okay, c of t, and if instead of this unit step response, unit step input, if we are giving a step input of amplitude a, we have to multiply the amplitude a with the entire our response. Okay, that is 1 minus e raised to minus theta omega t divided by root of 1 minus theta square sin omega dt plus theta. Okay, and the response will be like this, that is we are giving an input of unit step here, a constant value 1 here, and the response C of t will be an underdamped nature, that is the damping. Okay, the amplitude of the damping is reduces, and finally it settles down at 1. Okay, so I hope all of you understand the response of an underdamped system for a unit step input well. So thank you.